let's set up our first premise. Your family gets $1,000 to invest, and you have two options. You can invest in bonds. These bonds give 2% interest, simple interest. That means every year you get 2% of the 1,000 you put in every year, and then you can see what happens on the table. Down on the left side here, that's the bonds, and then there's also you can pay money to open a savings account and earn 2% compound interest, and you can see how that's going to manifest itself in the table there. Your job is to fill out the rest of the table and answer questions 1 through 4. We'll look at the graphing technology together, or we'll just talk about it. So 1 through 4 on the questions. I'm going to leave the view on this screen for you. First thing you need to do is fill out the table. So I'm going to run us through the bonds through 4 years. What's happening each year, friends? It's going up $20, and that's because that's 2% of the original value, $1,000 per year. That's called simple interest. Is this exponential or linear in nature? Linear. Now, this other one's a little trickier because it's compounded, and we need to know how often is it compounded. Once a year. So if I want to get to that third year, I need to do 1.02 to the third power. And I got $1,039.98. Okay. Then I multiply that by 1.02 for 2% increase. And I got $1,060.78. Okay, so this one, we're going to get there in a second. But is this linear or exponential? Is it going up the same? No, so it has to be exponential. Now I'm going to need your help because the questions are on the next slide and I want to see this slide. So who can read me the next question?
Which number 1?
Yeah.
How does the investment yield simple interest?
Okay. For the bonds, the simple interest would be 20 per year. Okay. You got to be careful because there's the 2%. There's no way to differentiate the 2% compounded versus not if you just say 2%. So 2% of 1,000 each year, that could work.
Yeah, that's what I did, 2% of 1,000, but
Every year.
What about
I did
So the other one would be
2% of 90?
2% additional from prior year or something like that. Right? Because with the compound, it's taking the previous year over and over, and you're getting 2% of that plus 2% of the next, 2% of the next. That's why that one is exponential. So question 3 asks for the function, correct? So who can help me out with the function for the bonds? All right, Brendan.
1,000 plus 20 times,
Yeah, 1,000 plus 20x. It starts with 1,000. It's getting 20 per year. What are some names for this number right here? Benny, give me a name for that number right there. That's a special number. It's 20, but that's not what's special. Yeah, JP. This is not exponential, so it won't have a growth factor. Slope, I heard over there, slope. Or rate of change, something like that, right? What about this number? That number's special.
Starting value.
Yeah, we're going to call it the y-intercept. All right. Then over here, who can help me with the function for the savings account? All right, Benny.
I'm going to give this one a try. I think I got it too.
I'll get you y equals. Then what?
Y equals 980
Okay.
times 1.02 y.
We can't have y twice. So we're going to put to the x. Yeah, the other thing you could do, so this is the one I would definitely use. I actually use that in my calculator. Another one you could consider is something like y equals 1,000 minus 20 times 1.02 to the x. I just kind of like that one because it shows that $20 fee. Like, it shows more of the context of the situation. But these are equivalent. And I would use the box one in my calculator all day. Are there questions on there? What's the next question?
Which investment option should the family choose?
Okay, which one do you guys think they should choose? Let's take a vote. Raise your hand for bonds. Nobody? Raise your hand for savings account.
Jason State Farm.
It depends how long. So, if you don't have it very long, which one's higher? The bonds. So, in fact, it's somewhere around year 11. They're the same. So, the way you would say that is, if it's 11 or sooner, let's do the bonds. If it's more than 11 years, it's going to be in there. Choose the other. Right? And these are like real decisions you'll have to make as an adult. Like, where should I put my money? But then you have to be like, well, how long is it going to be in there? Because depending on how long it's going to be in there, that'll make a change. For example, most retirement funds you can't touch till you're 59 and a half. So you're planning on that money being untouchable for a long time. So here's our next thing that you need to try. There's less context to this other than we have two functions. We have f of x equals 2x and g of x equals 1.01 to the x. Your job is to answer the questions. What's happening in the first one? What about the second? So you're going to talk with your partner. Just looking at the function, what are things you know about your function? All right? And then number 1, 2, and 3, you're going to fill out your table. You're going to say which one grows faster and say which one do you think is going to hit 2,000 first. But first, I want you guys just talking about what you know about these functions, just looking at them. I think the f of x one might be the easiest one to tackle first. I'm gonna continue my inputs on my table here. So when I put in 1 for x, 1 times 2 is 2. 2 times 10?
20.
2 times 50, 100, 200, 1,000. We got 2,000, 4,000, and 8,000. So what kind of function do I have there with that 2x?
I'd say linear.
Linear, right? Repeated addition is multiplication, 2 each time. So, g of x is different. What do we know just looking at g of x? What kind of function? Exponential. And where does it start?
1.01.
Oh, try again. Where does it start? 0. The initial value is 0. This starts at the origin. What is the 1.01? It's the growth factor. The initial, it starts as, we can test this out by putting, it's going to pump out 0. Right? It's going to pump out 0. So, actually I lied. It does not start at the origin. I'm a liar. It's going to start, what's the imaginary number out front? 1. It is going to start at 1. We can test it out by putting in x as 0. When we put x in as 0, what's 1.01 to the 0? 1. So it starts at 1. But for our function, to the first power, it's going to start at 1.01. Then in my calculator, 0.01 to the 10th. Then it just goes to 110.
After that, I got 1.6.
To the 50th, I got 164. To the 100, 2.70. To the 1,000, I lost my thing that I keep just editing.
144.77.
Oh, 1.01 to the 1,000? I got a different number than that. 1.01 to the 1,000, I got 20,959.
That's what I got. Should I come up with
Oh wait, I'm one away, but I'll write that down.
You skipped
Yeah, I skipped one. But I'll go back to it. To the 500, 144.77. To the 4,000. Oh, sorry, I keep skipping. To the 2,000. Woo! I'm gonna stop after this one. 86205.
Big number. Can't really fit it.
Some people might say sheesh. Okay. So, complete it. Check. Which function grows faster, Maddie? Maddie and I talked about this already. Yeah, I know, but you're not confused about it. I could tell by what you tell. What did you tell me?
I said that by like when x is like 7 or 800, like g of x, like something like that, bigger.
Yeah, so one way we could say that is f of x starts faster,
Finishes.
but g of x
Goes ahead.
owns f of x later on.
Just like Michigan State owns.
It's a classic rabbit. No, the tortoise and the hare.
Yeah.
Start slow and then just.
Slow and
See
steady
ya.
wins the race.
Which function do you think will reach 2,000 first?
Definitely G.
Yeah, we have some data
We got
right there, right? That's 2,000. That means g of x is going to happen to be 2,000 somewhere right in here, right? You guys seeing that? So g of x between 500 and 1,000. The input of 500 and 1,000, right in between there. It's going to happen in there somewhere. Yeah.
It's between 763 and 700.
So, Brendan found it's 763 point junk. Okay? Thanks for finding that, Brendan.
Thanks, Brendan.
And then we know that f of x doesn't get till 2,000 until input 1,000 exactly. Cool.